Assalamu alaikum. I am Kuratulan from Zoology Department of UOC and I am here to explain the topic electrophoresis. The word electrophoresis is derived from two Greek words electro meaning electricity and phoresis meaning movement. It's a technique used for the separation of charged particles under the influence of an electric field. It separates the biomolecules like proteins, nucleic acids, or amino acids according to their size, shape, and chemical charge, etc. This diagram shows the movement of charged particles under the influence of an electric field. Coming towards its history, the history of electrophoresis began with the work of Arne Tiselius in 1931. He gained the support of Rockefeller Foundation and new separation processes and chemical analysis techniques were introduced in 21st century. The methods spread slowly and more types were introduced in 1940s and 1950s. By the end of 1960s, increasing sophisticated gel electrophoresis methods make it possible to separate biological techniques based on various differences instrumentation. The apparatus used for electrophoresis is electrophoresis tank. The most basic electrophoresis system consists of a chamber, a membrane, electrodes, and a power supply. The chamber contains two buffer compartments at each end of a chamber. A bridge between the two compartments supports the membrane, which is typically consisting of cellulose acetate or some type of gel like agarose. Working. The working principle of electrophoresis is based upon the molecules, ions, and colloidal particles that are being separated. When the voltage is applied, the electric field allows the migration of the charged particles. The positively charged molecules move toward the cathode and the negatively charged particles move towards the anode. Since this process involves the movement of charged molecules under the influence of an electric field, this process can also be termed as electrokinetic phenomena. Types of electrophoresis. This technique is divided into two types, slab electrophoresis and capillary electrophoresis. Capillary electrophoresis is used for the analysis of food, pharmaceutical products, and environmental pollutants. It further includes gel electrophoresis and paper electrophoresis. The second type is slab electrophoresis. It is used to separate large biomolecules on the basis of size. It further includes zonal electrophoresis, immunoelectrophoresis, and isoelectric focusing. Here you can clearly see some of the types of electrophoresis. The first one is paper electrophoresis, in which a paper is used to separate the charges. The second is capillary electrophoresis, in which capillaries are used. And the third one is slab gel electrophoresis, in which the slabs are used for the separation of charges depending upon their size. Last but not the least are the applications of electrophoresis. It is used in agricultural testing, medical research, DNA sequencing, protein purification, and research. It is also used in food industry. It can be used for the separation of insulin, nucleic acids, phenols, amino acids, alcohols, alkaloids, carbohydrates, and organic acids. It can also be utilized in biochemical and clinical fields for the study of protein mixtures like hemoglobin, blood serum, etc. Electrophoresis in combination with autoradiography is used to study the binding of iron to serum proteins. It is also used for the study of steroids, terpenoids, and antibiotics. It is used for testing the purity of thyroid hormones by zone electrophoresis. Paper chromatoelectrophoresis is used to separate insulin from plasma protein. It is used for the diagnosis of various diseases of kidney, liver, and CVS. It is used for the separation of vitamins. Various antibiotics, enzymes, and RBC can be separated using this technique. Thanks for watching. Comment down below if you liked my video and don't forget to give a thumbs up.